Adrian. I'm also a student in the dual degree program and in the technical communications course.
I'm David, the technical communications course as well. I'm in the dual degree program also.
I'm Perez-Siam. I'm also a dual degree engineer. Adrian.
Well, what we're trying to implement is a new irrigation system that would be more, it would be run on a Wi-Fi system that would also conserve water and be less, it would require less labor. Some of the problems with the irrigation system that is running right now in Jacksonville University is, well, for first, that it is outdated, and the sprinklers are always running set on a clock-based system. So despite whether it's been raining for a week straight, the sprinklers will still be going on. This also has only a valve control system. This means that it only has the ability to turn the water on or off. So pretty much a 1-0 system, meaning the switches go on and off. So you can't be able to measure the amount of water that is going out of a certain valve. So, and there's also a overusage of water because of this.
All right, so we got our first solution to this was a Wi-Fi solution. We'd say that we use the school Dolphin Net to save money. You can run it off the computer, so you don't necessarily have to be at the school to be checking everything. So we don't have to come in every day, and if it's raining, they can just go on, okay, shut it off.
Right. In the long
So
run,
that cuts down on labor costs as well. And this is an example of one that they already have made. They're kind of the Wi-Fi, into the computer, it runs through a system out there. There's a bunch of green boxes. You may have seen them in the ground, and they have little valves in them that they're set on timers. So that'll take away that.
right, this system would be replacing the clock-based system that is already running in the school. Some technological solutions we've come up with for this project would be solar panels to run all of the electronics that we would add to this. There's several different types of solar panels that you could use. There's either you can have one base solar panel where they have all these solar panels to control all of them, or have single solar panels on each valve that would be responsible for powering that unique valve. This would also power the connection to the internet weather-based server. A lot of these RainNet programs that use the Wi-Fi connected to the school network are very easy to program. So using a simple if-then computer program, you can pretty much control when to turn on and off the water. Creating a simple computer program like such, we would be able to connect to a weather server and have an input and determining of what the humidity, the time of the year, also the actual type of zone that the water is plant. This would automatically tell whether to keep going on the regular clock-based system or to override it and shut off if it has been raining and the water is sufficient in that area. There's also, once we put in this new system, it will be able to measure the amount of water going through these valves. See, Jacksonville University uses about 76 million gallons of water a year just for the irrigation system, which is a lot of water. And we're hoping to reduce this amount by using these valve meters to measure how much water is going out, because most of these pipes are about anywhere 25 to 40 years old. So using this, we would be able to tell where the pipes are leaking, so you don't have to dig up all the lines just to notice. You'd be able to tell from the readings, and we'd be able to replace these pipes.
And we think that if we also swap out a lot of the plants, ones that use less water, more drought tolerant, such as Bermuda grass, the grass out there right now, I mean, if it doesn't rain, it's going to turn brown real quick. The plants that use less water, that's key. It's going to save a lot of water, save a lot of money in the university.
This wouldn't have been able to be done before, but there are new types of Bermuda grass that are actually more drought tolerant and also require less maintenance than the Bermuda grass that was available before. Bermuda grass requires a lot of sun, but these new types are are actually available to survive in shady areas as long as they get the sufficient water, which is less than the type of grass that is now in Jacksonville.
So basically, we got the Wi-Fi solution, which saves labor, costs, and then we got the pipes, which we'll have to do after we make the Wi-Fi. Got the solar panels and the plant swap. The solutions to save money for the university, save water, and save the environment.
We're hoping that this will be a flagship program so that after its success, it could be implemented in other commercial institutions and also other places that actually use more water than Jacksonville University does to be able to conserve water around the world and wherever it can actually be implemented. This will also save energy as well. So pretty much covering everything that the EPA wants.
Okay, we have time for a couple questions, Lauren.
What happens when the internet system goes down?
Right, if the internet system does go down, there is still ways to control it. It would just have to be manual like it is right now. But considering the Wi-Fi system, it's already based on a clock. So the only thing that would happen if the Wi-Fi does go down, it would just be running on the regular already clocked system that from those Wi-Fi networks that don't have to be connected to the network. The reason that they connect to the network is to be able to view the measure of the amount of water going out of the valves and also to get the information from the WeatherNet server.
Okay, thank you.
I saw one of those things that said rain gauge.
Yes.
Are you just bringing that offline, off the websites, or are you going to actually have gauges out throughout the campus measuring water?
Well, what we were thinking is have a water collector or a little rain gauge, and it senses how much water has rained over the past week or so, for the month, whatever it may be, and then it takes that, assesses how much it has, how much the soil is getting, and then judging by that, it will say, okay, we need to water a lot more, or we're good. We don't need it.
Because a lot of the ones that are already available are aftermarket products that only tell whether it rained or didn't rain. So if it rained for 2 seconds, it'll say that it rained and won't turn on the water, but then the plants will not have sufficient amount of water.
Probably time for one more question. So it sounds like you're wanting to expand beyond just the
Right, this would be a
just the
flagship
sprinkler
system where we
control.
would make sure that it has a great success here and then try to advertise it elsewhere.
Trying to cause that sensation.
I was thinking sensation, like the word sensation or something. I guess you meant. I don't know. Okay, let's thank our speakers. Next, I'd like to invite up our upcoming shrimp farmers.